Hi everyone, welcome back to Invent Academy. This is the final episode. Today we'll be building the digital piano project. And before we start, I just want to talk about the engineering design process. And this was the design process that I used to actually create this digital piano project. So this wasn't just a virtual project, but a physical object that I created. Um, so the problem was that I didn't have great access to a piano growing up. I did never had a full size piano, and I don't still to this day, but I do enjoy music. Um, so I wanted to create something that I could take out of my pocket and play notes on, since I was in the choir. So I created a design called the Pocket Piano, and it basically used push buttons, an LCD, and a buzzer. So it was pretty simple. Just take it out of your pocket. Unfortunately, I don't have it today since it's back at school. But I do want to share with you I do want to share this project with you. So I created a design using CAD. So what you just learned, this was done in um, Autodesk Inventor, not Tinkercad or Onshape, but it's pretty much the same thing. So I created this model, 3D printed it. Then I built the circuit. So it was done using a breadboard as well as an Arduino, as you can see. Um, so the same thing that we learned just physically that I had to solder it on. So breadboards are really good for modifying components, but if you want to create a more long-term solution, what you would do is use a soldering board as well as a soldering pen and basically attach all components permanently. Then I basically fitted all the components together. So I actually used a Arduino Mega, which is a lot bigger than what we're currently using in circuits. But pretty much there was a lid on it as well to just cover up all the internal components. But that's an example of what it would actually look like physically. And you don't need the LCD screen. It could be a lot smaller, but it doesn't hurt to build out. And then as versions go, you do want to make it a lot better. But the premise is that when you build something, you do want to always design it, then build it, then iterate on it to improve it. So that's basically the engineering design process. Finally, before we start, I do want to note that the frequencies in notes are actually exist. So C3 is this frequency, D3. These are all correlated with the piano notes. I do believe it's the third scale, just C, D, E, F, G notation. I'm not a pianist, so anyways, let's continue. So I'm going to make a new circuit. And just so I can minimize my screen. All right, so let's start off with the Arduino and breadboard as usual. So let's bring that in. And this is really great because the 5 volts and the ground are already laid out for you. So the power rails are already configured to ground for the black / negative rail, and 5 volts is configured to the positive or red rail. So let's bring in our components. So for this project, we'll need first the buzzer, which is also known as a piezo. Let's go to basic. Then, so it is a little big for this project, but not a big deal. In your kits, it might be a little bit smaller. Then we need push buttons. Push button, which is right here. So for this example, we'll just use 3. And that's really it. So now let's just wire this. So before we continue, let's distinguish that this push button, each push button describes a piano key. So for this push button, it will be C, and then this push button would be D, and then E, and then if you had more push buttons, F, G, A, B. but we definitely don't need to do it. It's just for the purposes of this demonstration. So let's wire this together. So we need to ground everything. So we'll put each push button to ground, as well as make the color of it black. And then we also have to configure each of these push buttons to a digital port. So that way we can read all these inputs, right? And we'll put it to 12, digital pin 12, 11, and 10. And we'll also make this red. Next, what we want to do is wire the buzzer. So we're going to put it to a special type of digital port, which is called the pulse width module. So it's more unique because it's able to get more of a range for what outputs or inputs it can receive. So I'm going to set it to digital pin 3. And the way that you know if it's a pulse module with pulse width module port is it has a swiggle on the right next to the number, so right before it. So I'll also make this red as well. And really that's all you need to wire up this circuit. So next we're going to go to the code. And for this demonstration, I'm actually not going to use block code. And the reason is that with push buttons, there's no way to set pull up. So we're actually just going to manually type this out. So I'm just going to go say OK for the text conversion, and I'm going to delete all this. So first, what we want to set up is our variables. So we have the push buttons, so that will be the keys. So I'm going to say C key, which is equal, or rather, you have to declare the integer type, the variable type, which is an integer. Then we have to declare the name, which will be the C key, and then we'll say 13, or rather 12. I believe we're starting at, yeah, so 12. And then we have to declare D, so D key, which is going to be pin 11. And then the E key, which is going to be 10. And the reason why we're using variables is because we don't want to reference 12, 11, and 10, because those are very difficult to keep track of. So we're going to use these numbers, these variable names instead. And then finally, we have the buzzer, so integer buzzer, and then we have it as digital port 3, so we're going to set to pin 3. So next, all we have to do is the setup. So the setup is basically where we declare which ports we're using. So it could be a digital input, digital output, analog. So first, we're going to start off with our push buttons. So we're going to say pin mode, and be careful because Arduino is very sensitive to syntax and spelling, so capitalization does matter. And we're going to say pin mode. So next we're going to start with next we're going to continue with the setup. So the setup is where you declare which inputs or outputs are being used, so the ports. And we're going to start with the push buttons and then as well as the buzzer. So we're going to start with pin mode, and then the push button. So it will be C key. And then for the push buttons in this specific configuration, we have to use something called input underscore pull up. So that's pretty important. Add the semicolons to complete your line of code. And then I'm just going to copy and paste it because we're just going to replicate it for key D and E. And then Finally, for the buzzers, we're going to use pin mode, buzzer, output. So that's our setup. Next, we're going to configure our loop. So what our loop does is it's the actual meat of our code. So we're going to tell our circuit what to do. So if you think about it, when you press on the piano, the action is when I press this button, or when I press this piano key, I should expect a sound. So instead of using an if statement, we're actually going to use a while statement, just because an if statement in a digital sense would be very instantaneous and you wouldn't actually hear the sound. So we want to use a while loop and it will play the sound longer. So we're going to say while, and we're going to say digital read C key. And what we're going to do with that information is set it equal to 1, or high rather. Okay, so now we're going to write the void loop of this program. So what the void loop does is determine and tell the circuit what to actually do within the program. So if we think about it, what we want to do is say when this So now we're going to move on to the void loop function. So what we want to do is say for this button pressed, right? We want a sound to be played. So that's what we expect of a piano. So instead of actually using a if statement, we're actually going to use a while statement. Okay. So now we're going to move on. Now we're going to move on to the void loop program. Now we're going to move on to the void loop function. The void loop determines what the program is actually doing. So in this case, when we press a piano key, we want sound to be played. So typically we would use an if statement. However, since this is a digital piano, if we actually used an if statement, you wouldn't actually hear a sound, or very faintly, just because we want our button press to be determined by how long we're actually pressing the key. So what we're going to do is actually use a while loop. So the way that this is done is by while, and then we actually do something called a digital read and the key. So this is going to determine whether or not the key is high or low, or whether or not it's being pressed. So we're going to use something called digital read and then double equals, which is a comparison. So we're saying, is this equal to something? So we're going to say low and then continue from that. So this basically means if the digital read is being pressed, so I'll put a comment, while it is pressed, we're going to complete this action. So this is the conditional, and then this is the block statement. So we're going to say, going referenced, I do have a list of what we should actually say or produce, what sound we should produce when the key is pressed, but I have it noted, so I'm just gonna write it down. So the tone for the C key will be tone, and then we say what item it is, so buzzer, and this is from the variable here. We're going to say 3081. That's what happens when we press the C key. So I'm going to copy and paste this for the D and E key as well. So D key, note this change, and then this will be 164.81. And this is actually 83, but it probably won't make, sorry, this is 130.81 and actually 146.83. And then for the E key, it will be 164.81. And then finally, if we don't actually close off the tone or shut off the buzzer, this would actually play forever until you decide to switch a key. So what we're going to do is say no tone and then the buzzer. And that would shut it off. So before I simulate it, I will warn you that it will not sound as pretty digitally as it would on physically if you were to actually have the physical circuit. So let's play this. And I do have some errors. So the error was, let's debug. I did not have a semicolon here, so I'm just going to put it right here. And then no tone is a capitalized. So no tone is actually capitalized here. So once we submit it, oh, and I did one more thing. I did forget to put the ground, the buzzer. So don't forget to do that. Now let's simulate it. So it's not going to be sound as pretty, but I will show you a physical version. So just hold on. So as you might have heard, they do have different pitches, right? So if you were to actually play Happy Birthday, you'd probably need one or two more keys, but they would be able to play whatever you want to do so. So now I'm actually going to show you what it would actually sound like in real life. So I actually built the circuit. We have the Arduino right here. This is attached using the USB port, which is right here. And then we have our push buttons, our wires to connect it to our Arduino, the buzzer. And if I were to play Happy Birthday, it would sound something like this. And that's just the first line, just because we don't have the, I believe, G key, so we can't get to the second line of Happy Birthday. But if you were to expand it, it's definitely possible to have all 7 keys of the piano for one scale. That's it to this episode. Thank you so much. I do recommend that you build this out physically in person with the actual board, but if not, this is how you would build it virtually. Thank you again for staying tuned to Invent Academy. Please be sure to share your circuit by going to the share, and then you can send us a Snapchat as well as get a link, and that is done and copied through this link. Thank you again, and have a great day. Bye.